So here is another question. It is given that a proton is placed in a uniform electric field of strength 6000 Newton per Coulomb and is allowed to go from one point to the other in the direction of the field. If the distance between the 2 points is 0.1 meter, calculate the potential difference between the 2 points, work done in moving the proton, and velocity of the proton at the final point. Okay, so here we have is the electric field. Okay, so it starts from positive and ends in a negative charge. Okay, so this is the electric field, the value of which is 6000 Newton per Coulomb. So here we have a proton, okay, with charge of proton plus 1.6 into 10 to the power 19 Coulomb. Okay, so it moves, let's say, from an initial point to final point. So let's say this is the initial point and this is the final point. The proton moves in the direction of the electric field. The positive, it repels the proton away from it. Now we want to find out the potential difference between these 2 points, delta V, which is final point potential minus initial point potential. Now we know that electric field is the negative potential gradient, okay, rate of change of potential with respect to distance. The negative of that is electric potential. Now we know here that the distance between these 2 points is 0.1 meter, that is the initial and final position. That is delta x, we are taking delta x considering that it is moving along the positive x direction because nothing has been mentioned about that, so we have the freedom to do that. So it is delta x is 0.1 meter, E is given already. So here 6000 Newton per Coulomb is equal to minus delta V by 0.1. That implies potential difference between these 2 points is equal to minus 6000 into 0.1, which is equal to minus 600 volt. This is the potential difference between the 2 points. Then the second part is work done in moving the proton from initial to final position. Now we know that the work done in moving any charge Q from an initial position to final position for a charge Q is equal to the value of that charge multiplied with the final point potential minus the initial point potential, or basically the potential difference between the 2 points. Now here we have already calculated that the potential difference between the 2 points, that is minus 600 volt. The value of the charge, the proton, is plus 1.6 into 10 to the power minus 19 Coulomb. So simply the product of that is 1.6 into 10 to the power minus 19 Coulomb into minus 600. So that is equal to, it is coming minus 960 into 10 to the power minus 19 joule. So here what this negative sign in potential difference indicates is that the final point is at a lower potential than the initial point, and this work done, which is also basically called as a change in potential energy, it means that the final point is at a lower potential energy than the initial point. Okay, the final point has less potential energy than the initial point. Okay, so this happens in the form of change in potential energy, which is the work done in moving the charge from one point to the other. Next is the velocity of the proton. Here another important concept comes into play, which is that change in potential energy of the charge whenever it is moved in an electric field, it appears in the form of kinetic energy. It is transformed into kinetic energy. Okay, this. Okay, change in potential energy appears in the form of kinetic energy. So kinetic energy of proton is 1/2 mass of proton, velocity of proton whole square. Now we know that mass of proton is 1.67 into 10 to the power minus 27 kgs. Okay, so here the kinetic energy is this much, the magnitude we are talking about. Okay, this much, 960 into 10 to the power minus 19 joule. That implies 960 into 10 to the power minus 19 joule is equal to 1/2 into 1.67 into 10 to the power minus 27 into Vp square. That implies Vp square is equal to 960 into 10 to the power minus 19 into 2, because denominator that goes upwards, that is equal to 1.67 into 10 to the power minus 27. Vp will be the square root of this, which will come as it is coming as 3.39 or 3.4 we can say, but okay, the second decimal point into 10 to the power 5 meters per second. This is the velocity of the proton. Okay, Vp 3.39 into 10 to the power 5 meters per second. So when it is moved from initial to final position, it will move at this velocity. Okay, so the change in potential energy appears in the form of kinetic energy. Okay, this is the thing. So here is another question on electric potential. It is given that 2 point charges of magnitude 100 microcoulomb and minus 400 microcoulomb are placed 0.3 meter apart. Locate the position of a point in between them on the line joining them where the electric potential is 0. Okay, so this is the thing. We have 2 point charges. Okay, so okay, this and this. Let's say this is point A and this is point B, and here we have 100 microcoulomb and here we have minus 400 microcoulomb. We have to find a point, a spot, let's say here, we call it P, which is, let's say, x meter apart from A. So the remaining BP will be 0.3 minus x meter apart, because the total distance between A and B is 0.3 meters. Okay. Now it is given that the potential at this point Vp is equal to 0 volt. We have to find the value of x. Okay. So here the potential at any point because of any number of charges, it is given by, here because of two charges, the potential at Vp will be the sum of potential due to charge placed at A, that is 100 microcoulomb, and the potential due to charge placed at B, that is minus 400 microcoulomb. So Va is equal to Qa by 4 pi epsilon 0 AP, and Vb, that is the potential due to charge placed at B, that is equal to Qb by 4 pi epsilon 0 Pp. Okay, this is the thing. Now okay, so here this Vp is equal to 0. That implies Vp is 0. So here Vp is equal to Qa, which is 100 microcoulomb, that is 100 to 10 to the power minus 6. 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 by Vp, which is equal to x, and plus minus 400 microcoulomb is 400 10 to the power minus 6 to 9 into 10 to the power 9 by 0.3 minus x. This is equal to 0. So here we can write it as 10 to the power minus 4, that 10 to the power, that becomes 9 into 10 to the power 5 by x, minus this becomes 36 into 10 to the power 5. Yes, the numerator, 36 into 10 to the power 5 by 0.3 minus x, that is equal to 0. That implies 9 into 10 to the power 5 by x is equal to 36 into 10 to the power 5 by 0.3 minus x. This gets cancelled, 10 to the power 5, 10 to the power 5, then it becomes implies 36 by 9 is equal to 0.3 minus x by x. This becomes 4. That implies 0.3 minus x is equal to 4x, cross multiplication. That implies 5x is equal to 0.3. That implies x is equal to 0.06 meters. So at a distance of 0.06 meters from charge A, that is the 100 microcoulomb charge point, this is 0.06 meters. At this much distance away from point A at P, the electric potential will be equal to 0 volt. Okay, so this is this.